Hello friends, good morning. Good morning to all of you. I am Dr. Raju, guest faculty at Endoc online classes. Endoc online classes is running for providing the best quality of education for the students who are preparing for NEET, JEE, and also for the students from class 6 to class 12. So, in my opinion, you must join this institute, this online classes, because it has decided to provide you the best quality of education that help you make your future bright. So, your future starts here, and if you want to improve your life and your education, you must join. Now, in this video lecture, we are going to talk about a topic related to chemistry. Yes, this is redox reaction, and very important chapter in chemistry that you must know very well, because it is basic for your preparation if you want to achieve good marks in your inorganic chemistry and physical chemistry as well. So now in this video lecture we are going to talk about topic oxidation number. So first we have to know what oxidation number is. Oxidation number uh, is defined as the charge that the atom has in a molecule, or would have in a molecule when electrons are completely transferred. You must have heard about this number, oxidation number. It's imaginary. It's maybe positive, negative, zero, or a fraction. So why we call it imaginary? Why? So so let us consider a chemical compound NaCl. NaCl, its name is sodium chloride. It is an ionic compound. It's an ionic compound which is composed of Na, sodium, or chlorine. In this molecule, sodium is present in Na plus form and Cl is in chloride form, Cl minus and Na plus. When to gain stability, sodium wants to lose one electron from its outermost shell, and chlorine has to accept one electron because it wants to gain a stability, and for stability octet rule has to be followed. So chlorine has 7 electrons in its outermost shell, and to make it 8, to have 8 electrons in its outermost shell, chlorine has to take 1 electron from other element. So chlorine is a nonmetal, and nonmetal has tendency to accept electron, and nonmetal as chlorine is going to form anion, that is atom with negative charge. Similarly, sodium is a metal, and metal has to lose 1 or more electron. So in this case, sodium has 1 electron in its outermost shell, and it's going to lose 1 electron and leading to form Na plus ion, that is cation, sodium cation, Na plus ion. and because we have complete positive and complete negative charge, and we know dissimilar charges attract each other, so there would be force of attraction between Na plus and Cl minus, and we have NaCl. So in this case complete transfer of electron takes place, but we have many compounds which are not ionic in nature, they are covalent in nature, and there would not be complete transfer of electron. There has to be sharing of electron between two atoms are there to form covalent bond or covalent compound. So in the case of covalent compound, oxidation number is defined as the charge that atom would have in a molecule if electrons were completely transferred. When electrons were completely transferred. So see here, this is CO2. This is CO2, and CO2 is not a ionic compound. It's not an ionic compound. It's a covalent compound. So there will be sharing of electron between carbon and oxygen. Sharing of electrons between carbon and oxygen to form carbon dioxide compound. But if you want to assign the oxidation number of each atom in CO2, that is carbon and oxygen, we have to suppose the complete transference of electron between carbon and oxygen occurs. So we have a set of rule for assigning oxidation number of atom in a molecule. So let us start to have a look at different rule for getting the knowledge how to calculate oxidation number. So the first point is in pre-state or uncombined state, an element has oxidation number of 0. In pre-state or uncombined state, where we have only one type of atom, or in also self-combined state, as we have S2, where two atoms of hydrogen are bonded together to form S2. Similarly, we have O2, N2. This type of state is known as self-combined state, where identical atoms, similar atoms are combined together to form molecule. So the first rule we have to remember the oxidation number of element in pre-state as well as in self-combined state is 0. That is, if sodium is in pre-state, its oxidation number will be 0. Similarly, if calcium is in pre-state, its oxidation number would be 0. If aluminium is alone, it's not combined with another element, so its oxidation number will be 0. So the most important line we have to remember, the oxidation number of element or an atom in pre-state or self-combined state must be 0. So this is our first point that we have to remember. Now, what about second point? The second rule is consider if you have Na plus ion, Ca plus 2 ion. So it is an ion which has only one atom. That is, in case of monoatomic ion, the oxidation number of an atom will be the number of charge with sign present on the atom. That is, look here. Na plus. This is Na plus. Na plus has plus 1 charge. So the oxidation number of or oxidation state of sodium is plus 1. Similarly, the oxidation state of calcium in Ca plus 2 would be plus 2. We have to write the oxidation number with sign because it has positive charge. Oxidation number would be positive. We know we have to remember the oxidation number may be 0, positive, negative, or a fraction. So in case of monoatomic ion, that is ion may be cation or anion, the oxidation number will be equal to the charge present on the ion. Now see the third point. Now we have to see the third point. The oxidation number of oxygen. Usually is -2. In most of the cases, the oxidation number of oxygen will be -2, and you know it is known as oxide. So in case of oxide, the oxidation number of oxygen will be -2, such as calcium oxide. In calcium oxide, oxygen is in -2 oxidation state. So most of the case oxygen has -2 oxidation state, number. But in case of peroxide, like S2O2, hydrogen peroxide, which is very, very important compound used in laboratory. So hydrogen peroxide has the oxygen present in hydrogen peroxide has -1 oxidation state. Look here, peroxide ion is O2 -2. O2 has -2 charge. In peroxide, both of the oxygen combine together to form a peroxide bond. This is called a peroxide bond. And this oxygen atom has -1 and this has -1 oxidation number. So in case of peroxide, we have peroxide bond, and oxidation state of each oxygen atom will be -1. So most of the case oxygen will have -2 oxidation state, and in case of peroxide it will have -1 oxidation number. Similarly, in case of superoxide, where formula is O2 minus 1. This is superoxide. So look here, 2 oxygen atom has -1 charge. So 1 atom of oxygen will have -half oxidation number or oxidation state. So in case of superoxide, the oxidation state of oxygen will be -half. So remember, in oxide -2, in peroxide -1, in superoxide -half. So this is about oxygen. Now as we know, group 1 of periodic table contains hydrogen, lithium, sodium, rubidium, cesium, and francium is a radioactive element. So lithium, sodium, rubidium, cesium, it will have +1 oxidation state. If it is in combined state, if it reacts with another element, so in the molecule, the oxidation state of lithium, sodium, rubidium, and cesium, also for hydrogen it would be +1. But in case of hydrogen, we have one exception. We have one exception called hydride. In case of hydride, hydrogen has -1 oxidation state. So if hydrogen is bonded to a very reactive metal, that is combination between metal and hydrogen forms metal hydride, and in case of metal hydride, the oxidation number of hydride will be -1. You must have seen compound, very important compound, calcium hydride, CaH2. The common name of calcium hydride is hydrolite. You must remember. So most usually hydrogen has +1 oxidation state, +1 oxidation number, but in case of hydride, hydrogen has -1 oxidation number. That you must remember. Now, the next point or the next rule is about fluorine. That is halogen. Halogen, that is 17th group of periodic table. Halogen group includes fluorine, chlorine, bromine, iodine, and the last statine. Statine is a radioactive element. So you must remember, fluorine is the most electronegative atom present in periodic table. So fluorine has always, with no exception, fluorine has always -1 oxidation state. Fluorine shows -1 oxidation number. Its oxidation state is always -1. But other halogen, that is chlorine, bromine, iodine. In case of halide, that is chloride, bromide, and iodide, as you know, chlorine has 7 electrons in its outermost shell, and to make it or to follow octet rule to gain stability, it has to accept 1 electron from from other element. So in case of halide, its oxidation number will be -1, and if chlorine combines with another more electronegative element like fluorine or oxygen, its oxidation state will be in positive. So so chlorine, bromine, and iodine shows its oxidation number from -1 to +7. +7 is maximum oxidation number of chlorine, bromine, or iodine, because it has 7 electron in its outermost shell. If we want to lose all electrons, because it has 7 electron, it can lose 7 electron, nothing more than that. So its oxidation state, maximum oxidation number or state will be +7, and minimum will be -1. That is, we have a range from -1 to +7 in case of halogen. But in case of fluorine, we have only one oxidation number, -1. Fluorine has always -1 oxidation number. Now, we are going to see the next point, and the next point is in case of compound, in case of neutral compound like H2SO4, H2CO3, because it's a neutral compound. It's a neutral compound. The sum of oxidation number of all the atoms present in a molecule or neutral molecule will be 0, because it has no charge, that is 0 charge. So the sum of oxidation number of hydrogen and sulfur and oxygen will be 0. The sum of oxidation number of all the atoms present in a molecule will be 0. That is, oxidation number of hydrogen plus oxidation number of sulfur plus oxidation number of oxygen will be 0. And oxidation number of hydrogen means total oxidation number of hydrogen, because we have to consider the number of atoms present in molecule as well, because here hydrogen is in a number of 2, so we have to take +1 multiplied by 2 for hydrogen. And like carbon, sulfur, nitrogen, and other halogen, sulfur also shows variable oxidation state. So the oxidation state of sulfur, in this case, we have to calculate by using this point. The sum of oxidation number of all the atoms present in a molecule must be 0. So let the oxidation state of sulfur be X. So we have 2 atoms of hydrogen here. So +1 for H hydrogen multiplied by 2, because we have 2 atoms of hydrogen, plus sulfur oxidation state is X, plus we know the oxidation state of oxygen is -2 multiplied by 4. It must be equal to 0. So solve this equation. 2 plus x, 2 4 ja 8 equals 0. So we have x equals plus 6. The oxidation state of sulfur, in case of H2SO4 is plus 6. So this is the method we are using for assigning the oxidation number of atom in a molecule. Now in case of polyatomic ion means an ion which has two or more atoms, like this is sulfate ion. So first we have to let the oxidation number of sulfur be x. So our point is the oxidation number in case of polyatomic ion, the oxidation number of each and every atoms will be the charge present on the ion or radical. So in case of polyatomic ions, the sum of oxidation number of all the atoms in a radical or in ion must be equal to the charge present on the radical. So the oxidation number of sulfur is x, plus for oxygen we have -2 multiplied by 4 equals 0. So x plus minus 2 4 ja 8. Sorry, we have -2 charge, -2 equals -2. So x will be plus 6. So the oxidation number of sulfur in case of sulfate will be plus 6. Similarly, this is permanganate ion. This is polyatomic ions. So the oxidation number, the sum of oxidation number of manganese and oxygen will be equal to -1. First we have to imagine the oxidation number of Mn will be x. So x plus we have -2 for oxygen multiplied by 4 equals -1. So after solving we get what? We get x equals plus 7. So the oxidation number of manganese in case of permanganate ion will be plus 7. Similarly, this is ammonium ion. And for N it is x. So x plus for hydrogen we know plus 1 multiplied by 4 equals plus 1. After solving, what we get? We get x equals -3. So in case of ammonium ion, the oxidation number of nitrogen will be -3. So we have a set of rules that we discussed In this lecture, we are using this set of rule for assigning the oxidation number of atom in a molecule. So so watch this video very carefully and try to understand what I want to make you understand. Thank you.